Manufacturing considerations in design. The knowledge of manufacturing processes is very important for a design engineer. So there are many manufacturing processes. The first one is primary shaping process. The process is used for preliminary shaping of the machine component. These kind of processes are called primary shaping process. The common operations used for this process are casting, forging, extruding, rolling, drawing, bending, shading, spinning, powder metal forming, squeezing, etc. The next one is machining processes. These processes are used for giving final shape to the machine component according to the planned dimensions. So common operations used for this process are turning, planing, shaping, drilling, boring, reaming, sawing, broaching, milling, grinding, hobbing, etc. Other type of process are surface finishing process. These processes are used for providing good surface finish for the machine component. The common operations used for this process are polishing, buffing, honing, lapping, abrasive belt grinding, barrel tumbling, electroplating, super finishing, choroidizing, etc. Next is joining process. These processes are used for joining machine components. Common operations used for this process are welding, riveting, soldering, brazing, screw fastening, pressing, sintering, etc. Next one is process that affect change in properties. These processes are used for to impart certain specific properties to the machine components so that they are suitable for particular operations or uses. Such processes are heat treatment, hot working, cold working, short feeding. Next we will see casting. It is one of the most important manufacturing process, and their castings are used are obtained by remelting of ingots in cupola furnace or some other foundry furnace, and then pouring this molten metal into metal or mold sand molds. Important casting processes are sand mold casting, permanent mold casting, stress casting, die casting, centrifugal casting. Sand mold casting is the one produced by pouring molten metal in sand mold. It is used for pots of larger sizes. Permanent mold casting castings produced by pouring molten metal in a metallic mold called permanent mold casting. Permanent mold. It is used for casting aluminum pistons, electric iron pots, cooking utensils, gears, etc. They have some advantages. They have they are having more favorable fine grained structure. The dimensions may be obtained with close tolerances, and holes of up to 6.35 mm diameter may be easily cast with the metal cores. Next is stress casting. It is a special application of permanent mold casting. This method is used for production of hollow castings without use of cores. Next is die casting. It is a casting produced by forcing molten metal under pressure into a permanent metal mold called die. The die is usually made in two halves, and when closed, it forms a cavity similar to the casting in the shade. One half of the die that remains stationary is known as cover die, and the other movable half is called ejector die. The die casting method is mostly used for casting of non-ferrous metals of comparatively low fusion temperature. This process is cheaper and quicker than permanent mold or sand mold casting. It has some advantages. The production rate is high, it gives better surface smoothness, the dimensions may be obtained within tolerances. Next is centrifugal casting. The casting produced by a process in which molten metal is poured and allowed to solidify while the mold is kept revolving. It is known as centrifugal casting. The metal that the poured is subjected to centrifugal force due to which it flows to the mold cavities. This results in production of high density castings with promoted directional solidification. Examples of cylindrical castings are pipes, cylinder liners, sleeves, rolls, bushes, bearings, gears, flywheels, gun barrels, piston rings, brake drums, etc. Next is casting design. The engineers must know how to design the casting so that they can effectively and efficiently render the desired service and can be produced easily and economically. The following factors must be considered in casting design: the function to be performed by the casting, soundness of the casting, strength of the casting, ease in its production, consideration for safety, economy in production. So, in order to meet these requirements, a design engineer should have a thorough knowledge of production methods, including pattern making, molding, core making, melting, and pouring. Next, we are going to see forging. It is the process of heating a metal to a desired temperature in order to acquire sufficient plasticity, followed by operations like hammering, bending, and pressing, etc., to give it a desired shape. The different types of forgings are smith forging or hand forging, power forging, machine forging or upset forging, and draw forging. Now, in forging also, the following should be points should be considered. The forged component should be able to achieve radial flow of grains or fibers. The forging which are likely to carry flash, such as drop and press forging, should preferably have parting line in such a way that the same will divide them into equal halves. The parting line of forging should, as far as possible, be in one plane. Sufficient draft on surfaces should be provided to facilitate easy removal of forging from the die. Sharp corners should be avoided in order to prevent concentration of forces. Next one is hot working. Hot working means working of the metals above recrystallization temperature. This temperature should not be too high to reach a solidus temperature, otherwise metal will burn and become unsuitable for use. The advantages of hot working is the porosity of the metal is eliminated, the grain structure of the metal is refined, impurities like slag are squeezed into fibers and distributed throughout the metal. Mechanical properties such as toughness, ductility, percentage elongation, percentage reduction, resilience to shock vibration are improved. Forging has got some disadvantages also. It requires expensive tools, it produces poor surface finish, and because of the poor surface finish, close tolerance cannot be maintained. Now, next we will see some hot working processes. Hot working processes are hot rolling, hot forging, hot spinning, hot extrusion, hot drawing, and cupping. Hot rolling is the most rapid method of converting large sections into desired shape. It consists of passing the hot ingot through two rolls rotating in opposite direction at the same speed. Hot forging consists of heating the metal to plastic state and then pressure is applied to form it into desired shape. Hot spinning consists of heating the metal to forging temperature and then forming it into desired shape. Hot extrusion consists of pressing the metal inside a chamber to force it out by high pressure through an orifice, which is shaped to provide a desired form. Hot drawing used for production of thick-walled seamless tubes and cylinders. Cold working. The cold working of metals happen below the recrystallization temperature. Most of the cold working process are performed at room temperature. The cold working produces following effects. The stresses are set up in metal which remain in the metal unless they are removed by subsequent heat treatment. Distortion of grains structure is created. Strength and hardness of the metals are increased. Recrystallization temperature is increased. Surface finish is improved, and close dimensional tolerance can be